So say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo.
Linear program is a method that we use to find a maximum or a minimum value given a list of constraints or a system of constraints. That maximum or minimum value is found as a part of the feasible region. We've been graphing systems of inequalities, and we have overlapping shaded regions. That overlapped shaded region is a feasible region. Now, that feasible region can be bounded where it's all closed in on all sides and it forms a shape, or it can be unbounded where it's closed in on part of the side, but part of it goes on forever. Our goal is to always optimize our solution. So we're going to look for the best price, or a way to minimize cost, or a way to maximize our profits. There are 6 steps to linear programming. Those steps are to identify the variables, identify the constraints, and translate them into a system of inequalities relating the variables. Then we're going to graph that system of inequalities and find all of the intersections that make up the feasible region, our vertices. Then we're going to write a formula or an expression to be maximized or minimized. We're going to plug in those vertices into that formula from step 4, and then we're going to interpret our results. So for example, if we're looking for maximized profit, we're going to look for the maximum. If we're looking to minimize our cost, then we're going to look for the minimum. The total number of workers' hours per day available for production in a skateboard factory is 85 hours. There are 40 hours available for finishing decks and quality control each day. The table shows the number of hours needed in each department for 2 different types of skateboards. We're going to say that X is the number of pro boards and Y is the number of specialty boards. They've organized our information here in a table, which is going to be beneficial when we're trying to write our system of inequalities. They've also identified a couple of constraints in our actual word problem. The first constraint that they've given me is that there's only 85 hours available for production. Then they've also told me that the total amount of hours available for finishing decks and quality control is 40 hours. We need to use all of our information to write a system of inequalities to give our situation. The first inequality that we're going to write has to do with the production time. 2 of the constraints that they give me in our problem is that there's a maximum number of hours for both production and for deck finishing and quality control. There's 85 hours available for production, and then there's 40 hours available for quality control. We need to relate all of our information in our table into an inequality. If I say 1.5 times the number of pro boards, that should give me the number of total hours spent on production for pro boards. Add to that the 1 hour times the number of specialty boards, which would give me the total amount of time spent on production for specialty boards. That total added together needs to be no more than 85. So I can use a less than or equal to sign to represent this inequality. I can make a similar inequality to represent deck finishing and quality control. 2 times x plus 0.5 times y has to be less than or equal to 40 hours. Now there's also 2 inequalities that we need to write here that I call our hidden inequalities. They're not represented in our table, but they're important to list. And that is that I can't have a negative amount of pro boards and a negative amount of specialty boards. We need to indicate that y and x both have to be greater than or equal to 0. In order to graph these inequalities, it may be beneficial to get y alone so we can determine a scale to make on our graph. When we solve the first equation to get y alone, we get that y is less than or equal to negative 3 halves x plus 85. The second equation, when we get y alone, becomes y is less than or equal to negative 4x plus 80. So we know that our scale needs to go at least to 85 because that's the y-intercept in the red equation. So I'm going to choose to count by tens. Make sure that you also label your axis. To graph the red equation, I need to first identify the y-intercept and then the slope. The y-intercept of the first equation is 85. So I'm going to go up 85 and put a dot. From there, I'm going to use my slope. The slope is negative 3/2, so I'm going to count down 3 and right 2. It is equal to, so I'm going to use a solid line to connect them. Since it's less than, I'm also going to shade down. The green equation has a y-intercept of 80, so I'm going to go up 80 and put a dot. The slope is negative 4, so I'm going to count down 4, right 1. Since it's equal to, I'm going to use a solid line to connect my dots. Y is less than, so I'm also going to shade down. My hidden inequalities, x is greater than or equal to 0 and y is greater than or equal to 0, indicate that I should only be graphing in the first quadrant. So my feasible region is whatever's inside this highlighted region, the green triangle. We also have to identify the vertices for step 3. One vertex is at 0, 0, where our two hidden inequalities meet. To find this vertex, I can put the two equations, y is equal to negative 4x plus 80, that's the green equation, and my hidden inequality, y is equal to 0, into my calculator and use the intersect tool to find what my vertex is. When I do that, I get 20, 0. My final vertex is also at my y-intercept of the green equation, 0, 80. We are attempting to maximize profit, so we need to write an equation on how I would calculate profit. They've given me that each pro board sells for $50 and specialty boards sell for $65. So to write an equation for profit, I need to indicate how much I would make from pro boards, 50 times the number of pro boards, and add that to how much I would make from specialty boards, 65 times the number of specialty boards, and that equals profit. I'm going to take each of my vertices and plug them into my profit equation. 50 times 0 plus 65 times 0 equals $0 profit. 50 times 20 plus 65 times 0 equals $1,000 profit. And lastly, 50 times 0 plus 65 times 80 equals $5,200 profit. Since $5,200 gives me the maximum profit I could make, that means that I need to make 0 pro boards and 80 specialty boards. Think of step 6 like the email that you would send to your boss indicating what your recommendation would be. You would tell your boss to make 80 specialty boards and 0 pro boards to get a maximum profit of $5,280.